Go to here. There we go. Thank you, Carlos, for telling me that we didn't have my microphone on. I had to switch screens, and we're live. I'll start over. Yeah, this is RockSim Live. We're talking about RockSim and how to use it. We can talk rockets, how to design rockets. Yeah, the floor is wide open today. We have somebody from Poland here. Mikola. I hope that's how you pronounce your name. Thank you for joining us all the way from Poland. It's got to be like 10 or 11 o'clock at night there. It's like really late. So, yeah, what are you doing up this late watching me? It's 2 p.m. Here in Colorado, so it's a nice, warm, sunny day. A little breezy, but you've got to take the wind. When the sun is shining, the wind is blowing because the sun heats up the earth. You get thermals, and the air has to fill the vacuum. So somewhere it's nice and sunny, and the air is going there, and high pressures and low pressures, and because of the sun. I blame the sun. We got Fat Bank from Texas. It's 10 p.m. there in Poland. Wow. Man, I'd be almost in bed by now. I get up early in the morning. I'm a morning person. So I'm up before the crack of dawn, doing exercises, getting ready for the day. Let's see, where are we? I did not bring a rocket today. I forgot to bring a rocket into the room with me, so hopefully we won't need a rocket. If you have a question about RockSim, go ahead and type it into the chat, and I will try to answer it. That is our purpose here, is to answer your questions, because you have the questions on how to use the RockSim, and I can try to answer them as best that I can. I'm learning myself, even though I've been using it for well over 20 years. We got Joe's High Power Rockets from Alamogordo, New Mexico. Love Alamogordo. I've been down there several times to fly rockets. Down there with the Las Cruces Club and the Alamogordo Club. Yeah, it's a beautiful field. Yeah, and you got the New Mexico. I forget the name of the space center down there. And then you got White Sands Missile Range, and yeah, lots of good, cool rocket stuff down there. I say down there because it's like due south of here in Colorado. Well, let me bring up my screen so you can see my screen. There's my screen. Let me bring up our website. If you are unfamiliar with RockSim, let me hide this favorites bar. It gives me more room on the screen. If you're unfamiliar with RockSim, RockSim is a model rocket design and simulation program. Where we can design a rocket and then simulate it. See how high it's going to go, where it's going to go, if the rocket is safe. Most important question of all. Performance is secondary, safety is always number one. If you're on the website at apogeerockets.com, if you go to the how-to and guides, if you click on that and come down here to software, this is kind of our menu. You can download a free trial. You can purchase it. There's the frequently asked questions, the system requirements, version history, and then over here on this side is more of the tutorials. So we have video tutorials. We have some common questions about loading missing motors back into RockSim. We have RockSim Live training, which is what we're doing today. And we have the RockSim Pro tutorials, which is similar to the RockSim, but it's specifically for RockSim Pro because that's a little bit different. The difference between RockSim and RockSim Pro is the Pro version is 6 degrees of freedom, which is this way, up and down, this way. Then you have into the camera and out. That's 3. And then you have pitch, yaw, and roll. As the rocket's going up, that's 6 degrees of freedom. Where RockSim is just 3. It's up and down, pitch, and then just one direction, upwind, downwind. So it's good, but in the Pro version, you get a lot more information about your flight, which you can make decisions, on. And then you can also see it in the launch visualizer. so you can see it in 3D. And you can, and if you don't have RockSim Pro and you want to use the launch visualizer, that's at rocksim.com, where you can check out the 6 degrees of freedom using designs created in RockSim. So you create them on your desktop, then you just upload them into the cloud, and you can run the simulations there and see it in 3D. And we'll probably get into that today because that's just so much fun to play with. So RockSim Live Training is where we're at right now. This is the RockSim Live Training, RS, which stands for RockSim Live, because we are live, and I'm going to make all the mistakes here live in front of you. This is not pre-recorded. This is recorded. This is episode number 67. Today is April 29. Is it the 29th? Wow, it is the 29th. 2022. This is number 67. This page shows you our archives. So if you have specific questions, you can come to this archive page, and it gives you the timestamp where that topic was talked about in that episode. So like in this episode at 10 minutes and 13 seconds, we talked about new t-shirts. And actually the t-shirt fabric came in today, and they are gray, as I talked about last week. And then we're going to start designing the decals, or, the artwork that goes on the shirts, and then hopefully very soon we'll be able to sell them. So the fabric is actually here in the house, which is like the hard part. Now everything else is just getting it up on the website. So that's coming. We have Vernon Gortz from Maryland. Hello, Vernon. I don't think I've recognized your name before, but thanks for coming. This is very fun. We're international audience again. What else can I tell you? Okay, so if you're on this page, let me show you a little trick that I use all the time on the Apogee website, because we got so much information on our website. So you come to a page kind of like this page, or our newsletter page, or the video page, where we have hundreds of archived documents, and you're looking for something very specific. So on your keyboard, hit Command F on the Mac, and then Control F on Windows, and that's find. And what it's going to do is it's going to throw up a little find screen up here in the corner. See, it showed it up there. And then you just type in a word that you're looking for, like mass object. Oops, you gotta type it right. And then it tells you it found one match. And then it highlights it on your screen where it is. And then you can find that information really fast. So we encourage people to use this little trick because it saves us a lot of time. When you find the information fast, it's gonna save you time as well. Okay, so I am looking for questions. Carlos K says, can you demonstrate role analysis in RockSim Pro? He's contemplating an upgrade. Okay, so this is RockSim. Let me open RockSim Pro. I can tell which one I'm looking at by up here at the top. It'll tell me if I'm RockSim or RockSim Pro. So that's RockSim. Here is RockSim Pro. So here it says RockSim Pro, and then I'm opening this design here. But let me open up something else. I'm not going to save that design, so I'm just going to get rid of it. Okay, come on. You got to open the other one that I wanted, though. Sledgehammer. Oh, it crashed. We're trying to fix this bug, and we're having an update, and my programmers just before this meeting said that they might have me a beta version by Monday. So I'm crossing my fingers. That's the one bug that we're trying to fix. Just a random crash when you close one window and open another. It doesn't happen all the time. It just happens only when you don't want it to. Okay, so open reset sledgehammer. Okay, so here is a rocket. This is a rocket that we just put out the plans for this in our latest newsletter that came out on Tuesday. If you're not a subscriber to the newsletter, if you go to the Apogee website and you go here to the home page, and one of these banners at the top will be for the newsletter, because we always keep that. And then you also got the slide out right there. So here's, and you sign up and you get 25 free plans, but we're continuing to add more plans into the newsletter. We're now over 20 new plans since that 25 free plan pack came out. So when we get up to number 25, then I'm going to have to start thinking about doing another free plan booklet. But you can also get the plans right now from the Apogee website. You just kind of scroll down and it will show you the latest free rocket plan. This is a three-dimensional drawing or rendering of the plan. This is generated in Adobe something or another. It's one of the Adobe programs. And this is three-dimensional, so you can move it around with your cursor. You know, you can zoom in on it. Whoop, I zoomed in too far. See, I can go inside. I can actually see the loop on the nose cone. But if you want the plans, just click on the link right below it, and it'll take you to our plan page. And here's all the plans that we've done. Well, probably about 80 to 90% of them. And if you scroll down up to this line here was the first 25, and then the ones down below are the next batch. And you can see there's a whole bunch there. And then here's the sledgehammer, and you can download the plans. It's a PDF, so if you click on that, it'll open the last newsletter. And as you can see, there's the sledgehammer, but then it's at the very back of the newsletter is the plans. Let me zoom out just a little bit so you can see it. So you got the fin plan form, you know, and how to lay them out on a piece of basswood. You know, all the dimensions, so you can build the plan. So you don't need RockSim for it, but if you want to modify it, like we're going to do here in just a second, then you do need RockSim. So there's the sledgehammer. So let's go back here. Okay, so roll. Okay, roll occurs when it can occur a couple of ways. One is called roll or yaw roll coupling. That means if the rocket yaws, this is where I wish I had a rocket with me. It's going to put one fin at a higher angle of attack, and when a wing is at a higher angle of attack, it generates more lift. So one fin generates more lift, and then it causes the rocket to roll. So it yaws first and then rolls. So you can see this in some flights. As the rocket's coming off the launch rail, it'll start rolling. And then in the other ways, you can induce a roll on purpose by canting the fins. So now that you put all fins around the rocket, and you have equal, each fin is at an angle of attack, so each fin is generating extra lift, but the lift is in the direction that the fin is canted, so then it will roll on its own. So first here, let me check these fins, because I was playing with this very rocket just the other day. I was doing this demonstration just for somebody else as well. So I have to make sure that I didn't adjust my fins. So I'm going to the fins, and I just want to make sure that I haven't tweaked them or canted them. So I'm going to open up the fins. So here's the fins. And then what I'm looking for is the radial position. Okay, this is one of the features in RockSim versus RockSim Pro that's different in RockSim Pro. In RockSim Pro, you can add a fin cant angle, which is right there. And I wanted to make sure that it was still at 0 degrees, and which is what it is. So these fins are perfectly straight on this rocket. So first I want to launch it and just get a baseline on how it's flying. So I'm going to clear out all these old simulations just so that we're starting fresh. So I highlighted all the simulations and then come down here to delete or I right-clicked with my mouse, and that brought up this menu. And then I just say delete. And it's going to ask me yes. You can also do that from up here in the simulation menu. You highlight them, and then you can say delete. So that's the other way of doing it. Okay, so let's load an engine. And to load an engine, you click on this icon up here. This is kind of like the base of the rocket with two arrows pointing downwards at the blast deflector. So we're kind of loading the rocket on the pad. So that's preparing for launch. And that brings up this screen, and you always start with the engine selection. And right now it's showing the engine mount, and I don't know if you can see it because it's green. So that's our engine mount. And we're going to put an engine in there. So you can highlight the row, and it tells me what the diameter of that engine mount is. It's 29 millimeters. You can either double click on the row or just select it and then choose engine. And it's going to bring up the engine list. So then I can pick and choose through this list of motors, and it doesn't really matter for simulations what it is, what you're starting with. So I'm just going to grab this one here, an F25, 29 millimeter diameter, has total impulse of 70.76 Newton seconds. And I'm going to select the ejection delay, and what I usually do is choose the longest one for the first starting, just to see what it's going to do, and then click OK. And so it loaded the rocket motor in the back, and then what we want to do here is just run a simple straight up launch with nothing, just to get a baseline. So under flight events, the parachute is selected to come out at maximum ejection delay. Starting state, we got a 98-inch launch rod. Let me bring that back down to like 5 feet, which is 60 inches. Right now it's 8 degrees from vertical. Let's make it 0. So let's go straight up. Okay, so it's straight up, and the azimuth is our compass direction. So think of this as a compass, where north is up, east is to the right, south is down, and here is west on the left. It doesn't, since we're going straight up, it doesn't matter which way the rod is pointed because it's going straight up. But if you were angling your launch rod, then, it doesn't really matter, like I just said. And I'm going to ignore this. I'll come back to this in a minute. Simulation controls, just leave it at default. Let RockSim Pro calculate it. So make sure that that's checked, and then ignores everything down here. Launch conditions, let me choose a launch site from my database. Huron Valley. This I think is NAR section 463. I think this is in outside of Detroit, Michigan. And then the wind table. Right now we have 4 mile an hour wind. Let's bump it up to 8 miles an hour. So I want to get a little bit of wind. And the wind is coming from the 270 direction. So it's coming out of the west. So north is 0, east is 90, south is 180, and then west is 270. Okay, and then let's hit the flight profile and watch this rocket take off. So it's running the simulation, and it's reached Apogee, and it's loading the launch visualizer. Okay, so it put the rocket on the pad. What you're seeing here is this cone. That cone is we call it the weathercocking cone. We want the rocket's apogee point to stay within the cone. Let me make this a little bit bigger, and then let's zoom out and just kind of get a perspective of where we're launching from. So it looks like we're in a park. Here's a parking lot. Right here, this is a major interstate. North is with the direction of the black arrow. So right now, north is downwards, and I can rotate that around. I'm going to swing it around so north is at the top of the screen. Okay, so my wind, remember, is coming out of the west. So the west is over here, this side, and it's coming this way at 8 miles an hour. Okay, so down here we have a view of the rocket, and we can watch that and then watch the trajectory at the same time. So I'm going to kind of zoom out a little bit. I want to see where that top of the cone is. And the top of the cone is like right around here, because that's it kind of gives me an indication of how high the rocket's going to go. And I want to look at it from trajectory view. Start with a trajectory view. Yep, it rotated it around again. Oops, spun it too fast. Okay, so now north is pointing up, but we lost our rocket. But if you want to find the rocket, you just click on this little button right there, and it says find the rocket. Okay, so my rocket is like dead center in the screen, so it's kind of like somewhere in this area. And then I want to rotate this way. Oh, okay, there it is right there, because that's the launch pad. Here's my cone going up. Okay, so the rocket's going to come up. This is what we expect. And it should arc over because we got a wind coming out of the west. And let's see if it does it. Okay, so the rocket is taking off. You can see the flame came out of the rocket. And the rocket is arcing into the wind a little bit. And it's going up high. You can see this right here is our smoke, and the smoke is blowing this way like we expected it. And at that point, the parachute is now out because the rocket is reoriented. If I pause it right here and I click find the rocket, it'll put the rocket dead center in the middle, and then I can zoom in right here and we can see a close-up view of the rocket. Okay, so we can see that the parachute is out on the rocket just fine. Okay, so I'm going to zoom back out. And I'm going to move it around a little bit, and then, oops, too high. This red line down here is the ground track. The green is the rocket's trajectory, so it went up to here. This green dot is our apogee point. The color is significant because that tells us that the rocket is inside the weather cocking cone at apogee. So that's good. That's what we wanted to see. So this is a good flight up to this point. And then I'm going to just drag the time slider right here. I'm going to drag it to the end, and then we can see kind of where the rocket's coming down. And it's really not in a good location because it's like kind of right in the middle of this interchange on the Interstate 96 right here. So up until that point it was okay, but it would landed here in a bad spot. Okay, but what we're interested in right now is the roll. So let's first go to a rocket view. I'm going to restart the simulation. I'm going to click on this button here, and that puts the rocket back on the pad. So now both of these views right here, this main view and the mini view, are the identical. So I'm going to turn this one off just to make sure that we can get more information about the rocket by seeing it. So I'm going to click the button here that says hide the mini view, and that goes away. Okay, so now when the rocket takes off, we can watch the fins, and from that we can see if the rocket has any roll. And I remember I said there's two ways to kind of induce a roll. One of them is yaw roll coupling. And we do expect the rocket to yaw because it is going to weathercock, so it is at an angle of attack. And so one fin should cause more lift, and it should, at least at the beginning, start spinning the rocket just a little bit. So if I hit play, okay, so it did it really quick. I don't know if you saw it there. Let me back it up. Let me turn off the smoke because the smoke is kind of obscuring things. So that's up here under preferences, under smoke and flame. And I want to show the flame, but I'm going to hide the smoke. Okay, so now when the rocket takes off, we'll see the flame. I'm going to turn off the weather cocking cone because we don't need that anymore either. So that's under the flight screen, display weather cocking cone. So turn that off. Okay, so now as the rocket comes off the pad, as soon as it clears the rod, it's at an angle of attack. And you can see, you can tell by the decal that the rocket has rolled. But once it evens out, it'll stop rolling. So as it comes off the pad, it rolled just slightly and then straightened out. Just like that. Okay, so fine. So let me close this, and we can see, you know, the statistics of this rocket here. It went, you know, 2,064 feet and reached 313 miles an hour. Okay, so now let's spin the rocket manually. And remember, you go to the rocket design components, you go to the fin set. We're going to edit the fins, so double click on that. Okay, and it brings up this editor. I'm going to look at it in 2D. Oops. Come on. There we go. Come on. There we go. 2D. My computer's kind of lagging today. Come on, I want to see 2D. Doesn't want to go. Let me save your changes. No. There's the 2D that I want to see. Oh, it crashed again. Ah! Let's try that again. Okay, open recent sledgehammer. Rocket, open recent. Okay. 2D. Clear these. Okay, I want to load back in my rocket motor. I want to rerun that simulation. F25-9. Starting state. We made that 60 inches. Choosing the launch site, Huron Valley. Wind table, and we made that 8 miles an hour. So I'm going to say 8 miles an hour from the west. Click OK. Okay, I'm just in case it crashes again. Okay, so I want to see that simulation. Did I do everything the same? No, I didn't. Remember, I didn't change the starting state. I had 8 degrees. That was the difference. So remember, the first time we launched it straight up. So launch, because it was over. Yeah, there we go. 2064. That's the right one. So let me get rid of that one. Delete. Yes. Save. Okay, so now we're going to edit the fins. You know, I can find the fins over here, double click on them. It should open up the viewer. Oh, this is doing to me again. I'll just leave it. Okay, going to the radial position tab. Okay, right now we have a fin cant angle of 0 degrees. That means these fins are perfectly straight. And we can cant them. I can do an angle here, but here's the thing. You won't see it in the drawing. That's an issue that we know about. You won't see them canted in the drawing, but they will be when it runs the simulation. But you won't see it you won't see them canted. But when the simulation runs, all the equations that it's using to run the simulation think that they are canted. So I'm going to cant them at 10 degrees. And then you can say, where is it pivoting from? And it's measured from the front of the fin. and at this point it doesn't matter, so I'm just going to leave that alone. Okay, so now the fins are canted, and we're going to rerun the simulation. So I'm just going to go back here. I'm not going to change anything. Leave everything the way it was because I want to compare apples to apples, and I'm just going to hit the flight profile button and we can look at it. Okay. Okay, so I'm turning that off. Make this as big as I can so you can see it. Oops, it went behind. Okay, so let's launch the rocket and then see what this one does. See, this one is continuing to spin. And the reason it's continuing to spin is because we have them canted. Okay, let's kind of pause it here. Reset it, but let me go to a trajectory view. And let's go back here. I spun it too far. Put north at the top of the screen. And then I want to pan the camera so it's tilted a little bit. Okay, so my launch point is right there. And let's launch it. You see the rocket's taking off. Now, I don't know if you can tell or not, but compared to the first flight that we did, this rocket is going a lot straighter up. It's not, the other one went right to the west. You know, it arced weathercocked into the wind. This one did not do it as much. I can look at the ground track down here at the bottom. Let me quit this thing right here. And I can see, you know, get a better perspective on what the ground track looked like. And this one, you can see it went a little bit to the west, but it also came a little bit to the south before it hit Apogee. And that's all because the rocket is rotating. And it looks like it's going to land about the same spot. We can just drag it down here. So by spinning the rocket, we're going straighter up. We get a much straighter trajectory, which is what we expect. It's like rifling on a bullet. You know, it flies straighter. But the thing that you'll notice if you come back here to the maximum altitude, even though it went straighter up, it didn't go as high. And the reason is because you're creating more drag because you're spinning the rocket. It takes energy to keep it spinning, and that energy has to come from somewhere. So it comes, you know, we lump it into the drag of the rocket. So the rocket is higher drag, but it goes straighter. So that's the trade-off on you know, canting your fins. Another thing that we can do here in RockSim Pro is we can give the rocket a rotation prior to launch. It's kind of like having a turntable on the ground on the launch pad. So the rocket on the pad is spinning. Remember, what was the first American satellite? It was launched on the Redstone Explorer 1. The satellite was spinning before the rocket even took off. So they had it on a turntable, and we can do that. First, let me uncant the fins. So I'm going back to the fins, and I'm going to turn them, it was 10 degrees, let me put them back to 0. Click OK. So now the fins are going to be straight again, but now we're going to spin the rocket, and you do that under the starting state. You have a starting velocity and a starting roll rate, and this is measured in degrees per second or radians per second. We'll call it 2 revolutions a second, which is not too fast. It's, you know, like that. So that would be 720 degrees per second. So it's twice, you know, 360 degrees is 1 second, or the first half a second, and then the second half we get to 720. So that's where the 720 comes from. So now let's hit that flight profile again. Okay, and let me turn off that. There's our rocket. Let's launch it. Okay, you see the rocket was spinning, but it kind of slowed down. But it's still spinning a little bit. And now the parachute's out. So let's pause it again. Let's look at a trajectory, see how straight it went. So let's put north back up to the top of the screen. Okay, so now this one, look at that. Remember the last time, it went a little bit to the west first before coming back around to the south. This one actually went east a little bit and then went south. And then somewhere around here at this point, the parachute popped out and then it goes straight east again. So if I kind of look at it more from the side, it looks mostly straight, but like I said, it did go a little bit to the south first. But now let's look at the altitude. Okay, so now we're back here. Look at our altitude. So now we actually went higher. So here's our first launch, no fin canting, just launched straight up. We went to 2,064 feet. By pre-spinning the rocket, we actually went higher. And we got that energy from the turntable that was spinning the rocket up. So the rocket didn't have to provide the energy, it was already there. So that's why we got more altitude here. So if you want to go higher, pre-spin your rocket. It's very hard to pre-spin your rocket though. There's 2 ways to do it. One is the mechanical turntable, and the other is to use a launch tower. It's called a helical tower because normally on a launch tower the rails are perfectly straight. But imagine 3 rails that are twisted. So imagine they're made out of like big long plastic noodles, and you fix them down here and you fix them down at the top, and then you take the top and you spin it like that, and that rotates them all the same amount. So when the rocket comes up, it's starting to spin as it comes out. So you can do that to induce a roll as well to make your rocket fly straighter. So that was a cool question to answer. Hopefully I answered what you were looking for, Carlos. There's some more text over here, so people must be asking questions. Johan is in the house from the Netherlands. Space Dog 49. Comparing different rocket simulators, RockSim always seems to predict higher maximum altitude by 20 to 25% over actual measured altitude from my flight computer. How do I adjust RockSim to better match? Okay, so the reason why this happens is because of drag. RockSim is trying to predict the drag, but it's obviously not being accurate enough. It's getting you in the ballpark, but not where you want it to be. So how do you adjust it? I'm going to go here into RockSim. So this is RockSim because it's a little easier to do here. And what you do is there's this tab right here called CD Override. So on this tab is where we can adjust the coefficient of drag to try to match real life. And how you match it is you're going to do what's called backtracking. and it's going to involve 2 flights. The first one is to gather data, and then the second one is now you can start tweaking things. So this is going to be complicated. We've talked about this a long time ago, but it's probably been a year, so we can talk about it again. First, let's run a simulation. So choose an engine, F25, 9. So I'm in RockSim now. So this is 3 degrees instead of 6 degrees of freedom. Simulation controls, starting state, it was 60 degrees. And straight up, launch conditions, 8-mile-an-hour wind, and let's launch it. Okay, so this RockSim predicts 2123. Okay, so now what he's saying is, okay, my altimeter read 2,000 feet instead of 2123. So how do we tweak the simulation to get closer to this value? And you do that with the coefficient of drag. So here's where RockSim is calculating the coefficient of drag. If you go up here to the rocket menu and then come down here to CD analysis, and this will give you an idea of what RockSim thinks the coefficient of drag is for this rocket. And coefficient of drag is dependent on the speed of the rocket and also the angle of attack. Like we just told you that, you know, when the rocket is rolling, we lump in the extra drag into the coefficient of drag. And that is because, you know, you got a higher angle of attack on the fins, which is causing roll. So angle of attack also changes the coefficient of drag. So this right here, this screen shows just 0 degrees angle of attack. So this is giving us just a little sliver of what's going on, only for one angle of attack. This is the hard part. So at 0 miles an hour, which is our current velocity, our coefficient of drag is 0. As soon as we move it, okay, so now we're at 64.5 miles per hour. Now we get a coefficient of drag of 0.319. And then if we go higher speeds, it came down a little bit, but then as we approach Mach 1, that's where we're going to get this big, huge increase in the coefficient of drag. And then you can see after Mach 1, in Mach 2, it starts leveling off till we're out here at somewhere around Mach 5. Okay, so that's what it's calculating. So now it's going to use these numbers. And so this is set up for a 3-stage rocket. So we have the CD for the sustainer alone, and then CD plus 1 booster, CD plus 2 boosters, and then we have the CD of just the booster stages by themselves. But for a single stage rocket, we're just looking at the sustainer alone. So we're just looking at this top number right here. So we're going to uncheck that box, and now I'm going to rerun the simulation one more time. So I'm just going to launch the simulation. Okay, so now it comes back, and it tells me at a CD of 0.75, I've got an altitude of 1,234 feet. So now our CD is off again. It's still off. Now we got to get it closer to the correct CD value. Since it's we're on the low side of the altitude, since we're below 2,000 feet, we need to lower the coefficient of drag so the rocket goes higher. So we're going to go back to CD and we're going to lower that value. So instead of being 0.75, let's make it 0.4. And now we're just going to run the simulation again. Just launch, let it run. Okay, so now we are higher altitude, but still not high enough. So now we're at 1764, and our target is 2,000. So come back here. Let's make it 0.25. Now let's run it again, see what happens. Okay, so now we're too high. So now we got to back it. We got to back it back up. So let's go to 0.35 and launch. So I'm trying to bracket. I'm trying to get as close as I can to get that right altitude. So we're now 1898. So now we're still a little bit too high. So let's come down to 0.33. Try it again. 1959. Now we're in the probably the third digit here. So let's go 335. No, we need to come down a little bit. 325. Let's go 29. No, let's go 8. I'm just 0.328. Oops, I just launched. 1965, so then we're still too high. 3, 2, 5, launch. 1975, getting closer, slowly. 3, 2, 3. Let's go 2. 18, another 10 feet. Oops, wrong button. Coefficient of drag. 3, 2, 0. Launch. We're probably still too high. 1990, and now we're 9 feet away from our target. So it's going to be like 3, 1, 8. Oh, we're so close. We're just a little over 1.5 feet. Okay, so now we're 1.5 feet the other way. So it would be 3, 7. So now we got to increase it just a little bit. 376. Launch it. Okay, so we're like really close. Now we're in the inches, just a little bit over 1/10 of a foot. So, just like within inches. So I'm going to call that good enough. So that's the coefficient of drag of the rocket. So now when you go out to launch and you want to put it in a different rocket motor, this is where it helps, because, running the same motor over and over again doesn't really do much. But if I put a different motor in there, say I put in a G motor, like a G64, 10-second delay, and then launch. So now what I hope is that this number will closer match the altimeter, the actual altimeter reading. So that's called backtracking. So we took a reading and then we backed out the coefficient of drag. Now, if you have a recording altimeter with an accelerometer on it, you can actually back out the CD a lot faster. And there's a process for that, and the process is on our website. So, and we go to the website. It's in the newsletter section, so I need to find the newsletter. How-to and guides, come down here to Picaflight newsletter, click on that, then go to all newsletters. So I'm going to use my little cheat. We're going to do the Command or Control F, and we're going to do, we can do either coefficient of drag or we can do backtracking. Let's try backtracking first. Okay, backtracking doesn't come up with anything, so let's do drag. It found 15 matches. Let me step through them. This is not it. Drag separation, drag. Okay, so issue number 303, how to determine the coefficient of drag of your rockets. If you click on that, it will give you a process for backtracking the coefficient of drag. And if you have a recording altimeter and you can make graphs, you can back out that CD a lot more accurately. Now, here's the caveat. Remember, we said that coefficient of drag is not a static number, and what we're doing right here with the CD is we are making it a static number. And in real life, that's not true. So this only works for your rockets that are going perfectly straight up with no wind. If you have wind, the rocket's not going to go as high because remember, it's going to weathercock into the wind. So then our coefficient of drag would actually be bumped up a little bit. So this is where it gets really, really hard. And then there's really no good way to do it except for computational fluid dynamics. And this is something that I would love to explore one day, but we're not quite there yet. So hopefully, Space Dog, that answers your questions. Yeet Forever says, just finished building my Estes Big Daddy. We sell the Big Daddy on the Apogee website. So if you go, oops, I'm in the PicoFlight newsletter. If I go to the top of there, and here I use the search bar instead of searching on a page because now I want to search the entire website. Big Daddy. Okay, so you can see that's how you find it. You start typing in it and it will bring it up. So if you've ever interested in the Big Daddy rocket, we have it here at Apogee. This is what it looks like. You can see it's a kind of a short, fat rocket. You can see how big it is. It's about that big. 3 inches in rocket specific, right? And that's right. It depends on the rocket because it's going to depend on, there's high drag rockets. Like the Big Daddy is a high drag rocket because it has a lot of base drag because it's short and fat. So you have to do it for every rocket if you're, like really, really concerned about it. Yeah. Space Dog says, my flight computer records acceleration at 500 hertz. Awesome, because yeah, if you're recording that acceleration data, that's good. So you're gonna have to do a little bit of data reduction, but it's totally possible, and they'll give you a good starting point on your coefficient drag. And Space Dog says thanks. Okay, so is there any other questions? Fatbank says, will the RockSim update include the option for canted fins or sub-minimum designs? Sub-minimum designs. I am not sure what sub-minimum designs means, Fatbank. I can answer the first question. Will the RockSim update include an option for canted fins? And the answer for that is no, it will not. And the reason for that is because once you cant those fins, now you're no longer in a 3 degree of freedom simulator. You need 6 degrees. But you can, in the RockSim.com website, you can perform 6 degrees of freedom simulations there. It's just you can't cant your fins there. So let me open that up, show you. New window. Okay, so I just want to go to RockSim.com. So this is the launch visualizer that I've been talking about. Right now it's loading. Okay, and it's going to load in a generic rocket right here. Here's the launch pad. There's our rocket. You can see this is this is full 3D. This is just an orientation to show you, the direction the rocket is pointed at liftoff. Let me log in under my account so that I can get into my designs. Okay, so now I'm logged in. I'm going to choose a design, and I have recently uploaded that sledgehammer design. So I'm going to select it because we've been playing with that design. So there's our rocket sitting on the pad. And in RockSim.com you can pre-spin the rocket. See, I have starting roll orientation, starting roll rate. So remember, we were at 720 degrees per second. Launch straight up at a 60-inch launch rod. Our wind was at 8 miles an hour, so let me select the wind, steady wind. And let's make it 8 miles an hour. Click OK. Load the engine. Come on. There we go. Choose an engine. There's our F-25. 9-second delay. Click OK. Let's set our launch field. I'm going to choose a launch site. There they are. I'm going to get that same launch site, Huron Valley Rocket Society. Click OK. Again, I don't think I showed you that this was in Michigan. So yeah, remember that view looks the same, except this time it's in the parking lot. We were in the field before. I'm zooming out so you can get a better perspective of where you are. Here's Pontiac, Michigan. Here's Detroit, Michigan right here. And there's the state of Michigan. It looks like, a mitten. So that launch site is right there. I'm going to zoom back in. I want to move the pad from the parking lot back into the field where we were before. So we were kind of launching over here. And so to move the launch pad from here to here, you just double click and then hit confirm launch site. And what that does is it reorients the latitude and the longitude and the elevation. Okay, and then we have set this to spin at 720 degrees a second, and we can launch it and simulate it. Now all this is running in the cloud, so you don't even have to load something. And again, what we're looking for is that rocket to spin as it takes off, and we can see it spinning. It's still spinning, still going up. Somewhere we got to be getting close to Apogee. And it's right there. And there's the green dot showing Apogee. We're obscured in the smoke right now. Let me back out a little bit. You can't see the rocket right now because it's too small, but it's hanging in the air. Let me turn on the trajectory. Show the path. Show the excluded path. Click OK. Okay, so now we can see where the rocket is. And again, let's see if it had the same trajectory as the one that we did in RockSim. Yeah, and it looks pretty close. Remember when we spun the rocket on a turntable. The rocket went south a little bit before it started going east. So that tells me that this is running the simulation the same as that RockSim Pro did, which is what everybody wants to know. Are they identical? Yes, it uses the same algorithm for computing the trajectory. So you can use this right now, but I can't cant the fins because I can't change the rocket. I can only change the simulation. Okay. Any last minute questions? Because we've gone an hour. Okay, there are no more questions. But I don't know what the question is about sub-minimum designs. What does sub-minimum mean? A minimum diameter design is the rocket is the same diameter as the rocket motor, because the rocket motor, it's got to go into the rocket somewhere. So that's called a minimum diameter. So what's sub-minimum? I don't know. I don't know. Maybe he must be thinking something different, which is totally possible. So, I'm going to change screens here. Okay, I guess that's the last call for questions for today. Yeah, lots of good questions today. We talked about rolling rockets, how to induce that spin, and then we talked about coefficient of drag. Those are our two big topics today. We will be back next week, but it will probably not be me because my daughter is graduating from university, and so I'm going to go visit her and watch that big ceremony going on. It's that time of year. People are graduating all over the world. And so, yeah, it's a big occasion for us because I get to kick one out of the house. I'm not actually kicking her out. She's getting married in June as well. So she's leaving on her own. So Michelle will be here filling in. She is really good at answering questions, the how-to questions. So have a lot of questions, because when Michelle does these, she doesn't explain them. She doesn't go as long or as deep into the topics. So she needs more topics. So get your questions ready on how to do things, because she's really good at answering those. And she's really good at finding the bugs too. All right, so until next week, have a great week. And in 5, 4, 3, 2, 1, go out and launch something.